Oh, hi. Today we'll be talking about non-Newtonian fluids.
Mix it up. Real life example of how the viscosities between Oobleck and water differ can be shown right here. Well, actually, the more interesting properties of this viscosity. As you can see, when I move this right to left, it's just like a liquid compared to water. But, alright, this is gonna seem a little weird, but watch what happens when I punch this water. Not very cool. When I punch this Oobleck, however, yeah. Nothing. That's it.
Okay, this is the drop test with a wrench-like thing. Ready? That's the water. Now let's try the non-Newtonian fluid. The sine wave general formula is represented as A times the sine of Wt, W being 2 pi times the frequency in hertz. Amplitude is represented with A, and in this case it's 1. We use 60 hertz as our sine wave because we've researched and found that 60 hertz is best with Newtonian fluids. We get sine of 2 pi times 60 times t, which equals sine of 120 pi times t. Next we have the period. The period is represented by frequency in hertz, equaling 1 over the period in seconds. 60, coming from here, goes here, which equals 1 over the period in seconds. The period in seconds equals 1 over 60, which gives us 16.67 milliseconds. Humans can hear in a range of 20 hertz to 20,000 hertz. The hertz we used were 60 hertz, which are in the very lower end of the spectrum.
The most interesting thing about non-Newtonian fluids is the viscosity. Viscosity is given here by this formula. F is the force, mu is viscosity, A is the area of each plate, and the ratio of U over Y is the rate of shear deformation or the shear velocity. Now the special thing about non-Newtonian fluids is that they have variable velocities. Newtonian fluids will have their mu as constant, so constant viscosity. However, non-Newtonian are defined by mu equals the force and the shear strain rate. This is an inverse relationship. Since the equation is like this, as the force increases, the shear rate decreases. So, the fluid thickens when subject to a force. Oobleck, which is what we use, the non-Newtonian fluid, is a dilatant material. Therefore, its viscosity increases with the rate of shear strain. Liquid. We're going to go from 366 hertz down to 60 hertz, which we researched and found was one of the most optimal for this type of experiment with non-Newtonian fluids. So we're going to go ahead and start now. We're now at 60 hertz. you!
You like that? I like that. You like that?
Y'all ready for this?
Solid, 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 liquid.